Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate, Uncut and After Show. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate pre-show and after-show goodness. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they premiere, and there's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the show, you'll have to check out this stream because it's on Nathan Oakley on a Thursday for the second show. But while I set up for that second show on the Nathan Oakley channel, I'm going to pass over to the live panel and Skype so I can do exactly that.
It's very small because the air goes down.
So the air in the
acceleration
upper
constant
atmosphere
has
won't
nothing
connect
to do
with
with the law of thermodynamics and air pressure.
Obviously, it doesn't, but the law of thermodynamics is it has a how should I call it? It has a correlation to it because sure.
No.
If you apply force to a gas, the gas will rush. Look,
well,
if you have,
no, it won't. No, it won't. It
I know
won't
it's hard
rush
for
anything.
someone else to have a
It's just going to
conversation.
realign the density buoyancy alignment.
Have a say into this. Now, I would like for Brenda or Zynder or whoever to explain how a pressure gradient forms next to a vacuum.
It doesn't.
Magic of gravity.
I know. I'm not asking you, Arwen. I'm asking them.
Gravity.
How does a pressure gradient form within a vacuum?
Electrolyte.
Gravity.
You know, it has electrolytes, like Brenda.
Hold on, Anon. Just let Brenda answer.
Yes, Vanilla, be quiet. Gravity exerts a force on the gas.
Now, so you're talking about Newton's force? Gravity is a force? Or are you talking about Einstein's force is not a force? I mean, gravity is not a force.
It's not really relevant.
Just 9.81 meters per second squared.
No, it's not relevant.
No, it is.
Force, this equilibrium present could ever contain gas.
Please,
Owen, come on. Just
never happened.
Owen, let even just quiz Brenda for a bit.
So, Brenda, gravity. You're saying gravity is a force.
It can be described as a force.
Doesn't matter.
So when can it not be described as a force?
I don't know what you mean.
You said it can be used as a force. So when can it not be used as a force?
When you're not describing gravity.
Yeah, I know you're describing gravity. So
yeah,
describe
gravity is the what? Newton's formulation of gravity is the description of it. It tells us the what of gravity. Einstein tells us the why of gravity.
So what is gravity? Is it a force?
It can be thought of as a force. It's a displacement. It's a displacement of things when they're due to the bending of space-time.
How do you measure it?
Which can be described as a force.
Well, how do you measure the force in the bending of space-time?
What do you mean?
You're the one who understands it.
Hold on, just repeat it.
How do we measure the force of gravity?
How do you measure the force of gravity within the bending of space-time, like you were saying?
Yeah. With the Cavendish experiment.
Cavendish experiment measures the force between two masses. It doesn't measure anything with the bending of space-time.
That's what gravity is.
Yeah, but not with the bending of space-time, like you're saying.
That's what gravity is. It's two masses will bend space-time.
The Cavendish experiment happened. The Cavendish experiment happened 150 years before Einstein formulated that equation for the bending of space-time.
Yes, that's true.
So Cavendish knew Einstein's field equations before Einstein?
No, he didn't.
So how did he know that the gravity is the mass between two objects within bending of space-time?
Can you measure temperature without knowing?
Does that have anything to do with gravity?
Excuse me, do I get to talk or not? Can you measure temperature without knowing about the atomic theory of temperature? Yeah, you can.
It has nothing to do with the measurement of gravity.
It means that
with the bending of space-time 150 years before.
You can measure things without fully understanding the phenomenon that explains why they happen. As I said, Newton gave us the what. He described how gravity affects things around it. Einstein gave us the why. He explained why it happens the way we observe it to happen.
So scientific theories explain laws, is what you're saying.
No, scientific theories explain observations.
No, you just said that Einstein's theory explained the why, and the law was the what.
No.
Yes,
yes.
It's what you just said.
Yes.
So, do you understand that laws and theories are two different things?
A scientific law is a numerical formulation of repeated.
It's a description of the what?
Natural law.
Yeah.
It's a description of the what. But
yes,
theories are explanations of the how and why.
Yes. If theories are explanations,
if Einstein's theory explained Newton's law, then Newton's law wouldn't be a law anymore.
Sure it is. It's still a law.
Sure it is. You don't know the difference between a scientific theory and a scientific law. Does a scientific law go through the scientific method?
Yes, it's based on observation.
Oh, it does. Okay. Let's go. Nathan, I'll share my screen. Hello?
Yeah? You hear me?
Yeah. You got it?
Yeah.
Okay. 1 second, please. Natural phenomena observed, please.
Bending of fabrics, bro.
Bending of fabric. Come on, Brenda. Natural phenomena observed, please. Newton's
I don't
law.
know. What are you talking about?
Something about a trampoline. You put a bowling ball on a trampoline.
Hold on
or
a
some
second.
shit.
With the trampoline nonsense. Stop interrupting the discussion. You said a scientific law goes through the scientific method. I have the scientific method on screen right now. We are going to go through it with Newton's law. Natural phenomena observed, please. You're going to support what you claim. Go.
All I see is a lighthouse and a boat in the foreground.
Natural phenomena observed is a lighthouse.
All I see is a sunset.
No, it's a sunset. The natural, like the scientific method became a sunset.
Oh my goodness.
It was a lighthouse.
Zynder, calm down. Calm down. You guys are off the reservation. She said that Newton's law went through the scientific method. So, what did Newton observe in the natural world?
He observed the phenomenon we call gravity.
So gravity is your observed phenomenon.
Yes.
All right. Oh, sorry about the A. Gravity. So what's gravity look like? You have a picture of it for us?
It's a phenomenon.
It's a phenomenon. Do you know what an ipsy-dixit fallacy is?
It's describing a behavior that is observed.
No. You have to observe a phenomenon. You have to observe it. Physically observe it.
Yes, that's what a behavior is. It's something you can observe. You can observe behaviors.
Okay, I'll roll with it. Gravity. So that's your dependent variable, right?
You observe.
We observe gravity, so this is going to be a circle jerk, right? You're trying to prove gravity, but you're already observing it.
No, I'm not trying to prove gravity. We observe gravity.
You're not trying to prove gravity?
No. It's something we just observe.
Law of gravity is. You said it went through the scientific method. So he observed gravity. Okay, what's the hypothesis?
He observed gravity from which he formulated his laws.
Go ahead. He observed gravity, and now he's going to make gravity laws, right? That's brilliant. What's the charge, mass, momentum, or spin, or chemical formula or structure of gravity?
Right. Science, that would explain the why. He just described, Newton just gave us the what.
Okay, that's what we're doing. We're going through the scientific method. You said it went through the scientific method. Let's go.
Right. It's repeated experimental observations.
Alternate hypothesis, please. You said gravity. Give me the hypothesis.
No, it's a description.
No,
it's not a
yes.
theory.
You said it went through the scientific method. We're doing it right now. Do it.
Right. So,
alternative hypothesis, please.
Newton's laws are based on repeated
alternative
experimental
hypothesis, please.
From which formulated his laws.
Give me the alternative hypothesis for Newton's law.
That I don't know.
Oh, you said it went through the scientific method. That's quite explicit.
It's repeated. It's repeated.
No. Don't tell us what you think the scientific method is. You're being asked for a hypothesis.
Hey, Nathan, somebody
Brenda,
just said that they don't see my screen.
Google it, Brenda?
Yeah, unfortunately, I can't share Skype in the Hangout. It just doesn't let me do it. It's kind of moot at the moment because I'm literally going to start the live show. So.
Oh, I'm sorry. You're not on the live show.
Well, we will be in about 20 seconds.
Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate Forum. And if you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live. And there's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Zynder, Slick James Johnson, Paul, I can't quite see the screen, Nathan, Eben, Chocolate Saying, Brenda, Anon, and is it Johnny Globehead or John?
Quantum Eraser.
Quantum Eraser. Good to have you all.
Hello.
Hello, good to be here.
Hello, I just got Brenda phenomenon, by the way.
Good morning.
Morning, Nathan.
All right, so a scientific law, right?
Hold on a second. Nathan, could you share my screen or no?
Yeah.
Hold on a second, because we're going to get back to the discussion. She said that Newton's law of gravity went through the scientific method, so we're going to go through the scientific method. She is going to support what she says. So, to get everybody up to speed, her natural phenomena observed so far was gravity, and I'm asking for the alternative hypothesis. That's where we're at. You're all up to date. What's Newton's hypothesis?
So it says Newton's laws are based on repeated experimental observations.
Now I'm going to ask you for the 10th time. You said your natural phenomena observed was gravity. The next step is alternative hypothesis. Give us Newton's hypothesis.
He wasn't formulating a theory of gravity. He was formulating the laws of gravity.
Nope, you're obfuscating. You said Newton's law went through the scientific method. I have the scientific method up here on screen. So you said the natural observed phenomena. Shut your pie hole. Natural phenomena observed was gravity. We're going through the scientific method as you claimed. You're going to support your claim right now. Is there anything that's particularly confusing about this?
This is the scientific method.
That's right.
Law,
So, alternative hypothesis.
Laws are formulated
Here we
by
go again. Just
experimental observations.
Yeah, so experiments are hypothesis tests, and he's asking you for the hypothesis. So if they're done with experiments, it's established through experimentation, like you've just declared. Well, first we need the hypothesis, because we're going to perform, according to you, hypothesis tests. So just give me the hypothesis. What's Newton's hypothesis? Simple. Tell us.
Well, his hypothesis would be that if I drop this pin, it will fall at 8 meters per second per second. Right?
9.8.
9.8.
It's okay. We got it.
9.8
Hold on.
meters
It's just right. It's okay. He's just writing it down.
If I drop an object, it will fall at 9.8 meters per second per second. That's the hypothesis. The alternative hypothesis. Well, actually, that's the null hypothesis. The null hypothesis.
The null hypothesis is the no difference hypothesis. So wait, before we get there, if I drop this pin, it will fall at 9.8 meters per second squared. Sorry about that.
That's the null hypothesis. The alternative
That's
hypothesis.
not the null.
Yes, it is. That's the null hypothesis.
This is not the null. I need a citation for that hypothesis, please.
So the alternative hypothesis.
I need a citation for the alternative hypothesis, please.
The alternative hypothesis is that if I drop this object, it will not fall at 9.8.
No, you got them backwards. You got them backwards.
Brenda,
null is
what does null mean?
Ask Quantum Eraser what the difference.
What does null mean, Brenda?
Ask him.
He knows. I'm asking you.
Okay, wait a second. We're going to solve this quick because it's a train wreck. First of all, you got the alternative hypothesis and null backwards. Second of all, this isn't a hypothesis, and this sure isn't Newton's hypothesis. You know why? Can you tell me why that's not Newton's hypothesis?
No, go ahead. Tell me.
We'll take it right from the Principia. 1 second. Give me a second, please.
Newton didn't have any math in his hypothesis.
From Newton, from the Principia, Isaac Newton, 1726. I have not, as yet, been able to discover the reason for these properties of gravity from phenomena. And I do not feign hypotheses. Or hypotheses non fingo equals I feign no hypothesis. I frame no hypothesis. I contrive no hypothesis. So you just made it up.
Yeah, that's
you
he's talking
just
about
made it up.
Talking about the
that
theory.
You just made it up.
He's talking about the theory.
No, he's not.
Brenda, you sound like a jackass.
No, he's talking about the theory of gravity. He said, "I feign."
Newton never proposed this theory in his life.
Feign no reason, meaning I feign.
No, I do not feign hypotheses.
To explain the theory, I simply
there
describe
is no theory. Newton never proposed a single scientific theory in his life. We're talking about laws. Remember this? You said that Newton's law went through the scientific method. So we're back to this again.
Yes, it does.
Right.
That doesn't mean it.
So we're back here again, right? He had no hypothesis. This is not Newton's hypothesis because he didn't have one. We just read
he
that.
didn't explain. He did not explain the why. He explained the what.
Didn't have one. That's right. So it didn't go through the scientific method. My whole point.
That's not true.
So that's a great argument.
You don't have to have a theory.
You are a clown, period. We just demonstrated that. So thank you very much.
I think you're equating observation with experiment, and they're not the same thing.
Brenda thinks just doing observation is science. That's a problem. It is, right? Just like naming things. That's science, right? Naming things.
Yes,
you attach a name to something, that's science in it? Yeah, Brenda. Go ahead. Keep going.
Brenda, how is the mass of Earth calculated? Do you know what the mass of Earth is?
So Newton prescribed gravity, right? He formulated his law.
Do you know what the mass of Earth is?
Oh, I'm not changing the subject.
I am changing the subject. Do you know what the mass of Earth is?
I'm not changing this. I'm not.
I am changing the subject. What is the mass of Earth?
I don't know.
You don't know? You don't know what the mass of Earth is? I thought you were a scientist. 5.96 trillion tons. How is the mass of Earth calculated?
You can weigh it.
It's weighed.
Yes.
That's how you know what it is.
Yes.
You don't know that it's calculated using Newton's gravitational constant?
Yeah, that's
weighed.
That's weighing it. That's called weighing it.
Okay, so what's the calculation? How is it weighed?
If you have two objects, right? In the formula, big G equals little g times mass 1 times mass 2 over the square root over r squared, right? So if you know one of the masses, you can calculate the other mass.
How do you calculate the difference between the radius of the sun and the Earth?
If you we're not talking about the sun.
That's how Cavendish got the gravitational.
No, he didn't. No, he didn't.
You're saying he didn't?
No.
So, how do you get the mass of the Earth then?
You get the mass of the Earth by weighing it.
Thank you. What scale did you use to weigh it? Was it something you can buy on Amazon?
No, you use a scale. Yes, you can weigh the Earth with a scale bought from
How
Amazon.
much is the scale worth? I mean, where do we place the scale on?
You'd have to get a rather expensive one that can.
I know it had to be big enough to fit Earth. I mean, where do you find? How do you build such a scale?
No, you don't have. It doesn't have to fit the Earth. It only has to fit the other mass.
What's the other mass?
Well, there's two masses, right? Mass 1 and mass 2.
Okay, so what's mass 1? What's mass 2?
Mass 1 would be the Earth. Mass 2 would be an object that you choose to weigh.
So what's the object that you choose to weigh?
Whatever you wish to choose.
The Earth,
so what
please.
do you choose?
Sorry, hold on a second. Hold on. We seem to have gone off on a slight tangent. We're talking about weighing.
Of course.
Well, you said, Brenda, you said any object. Okay, Earth.
No, mass 1 is Earth.
Yeah, and we're weighing that mass, right?
Right, and you weigh it by weighing another object, mass 2.
Okay, toothpick.
Sure, in principle, but not in practice. You could weigh the Earth using a toothpick.
Right, that's the stupidest thing I've ever heard.
No, it's not. In principle, you could do that. In practice, it would be incredibly difficult. We don't have scales sensitive enough to do that.
Maybe in the 1700s we had those
So
scales.
you say we do have a scale.
Yes, there are scales that are sensitive enough to make measurements that we can come to a approximation of the weight of the Earth.
So it's an approximation scale. I have those scales.
No, this is not.
I think it's like $1.99 at the general dollar store.
All scales have a degree of accuracy, right?
They're gravity meters, right? Scales are gravity meters?
Essentially, yes, they are.
Do you recommend one? I want to buy one.
Just use the one you use to weigh your weed with.
Weed? You mean after I mow the lawn?
I'd like to ask Brenda a question that might get us back on track a little bit, right? I know we're off in the weeds somewhere.
Go ahead.
Brenda, let's go back to the pen, okay? I observe a pen falling. So what I'm observing is something going from my hand to the floor. That is what?
Yes.
What is the cause? What is the cause of the pen going from my hand to the floor? How would you determine? Okay, well then go through the process and walk us through that process of determining that that's gravity.
Well, we would just call that gravity because a force was applied to the pin. Right?
How would you prove it's a force? How would you prove it's a force?
So we just observe it, right? You let go and it moves.
No, we're still seeing a phenomenon, but you've got to prove it's a force.
Well, when you let go of it, did it hang in the air or did it fall?
Oh, sorry to interrupt. Sorry, Paul. Sorry. Are you saying that you first picked it up? Because that would be the cause. You picking it up and dropping it.
Me picking it up is not the cause of it falling.
Well, yeah, you picked it up and dropped it, didn't you? Okay, so I've got a pin in front of me. I've got it right now. I'm looking at it. Right. Why isn't it falling, Brenda?
Because you're holding it.
No. I'm looking at it. It's on the side of my desk, but it's definitely not falling. Are you saying that pins fall of their own volition randomly in nature? That's a phenomena we can observe. Or are you causing it when you pick the pin up and drop it?
No, you're not causing a pin to fall when you pick it up.
Well, I'm looking at a pin and it's just not dropping at all.
Right.
So when you say pin, do you mean pin with the caveat that a man's got to pick it up and drop it? Because I would say that that's the cause, wouldn't you?
No, I wouldn't say that picking up a pin causes it to fall.
Okay, again, I'm looking at a pin and it's not falling.
Right.
Yeah, so it's not falling, Brenda, so it doesn't fit the criteria. How am I going to measure it falling if it's not doing that?
Well, you would pick it up.
Oh, well, that would be the cause of it falling then, wouldn't it? You picking it up. There we go. Cause and effect established. Jolly good. So you're causing it to go up in the air. You're giving it energy by picking it up.
Right. Yes.
Well, that's the cause. That's your cause. That's your cause. There's your cause. There's your cause. There's your cause. If you hadn't picked it up and dropped it, it would have just done what my pin's doing, which is not dropping. So there's your cause. Not gravity. You picking it up and dropping it.
No, that doesn't follow at all. So suppose I pick it up and hold it. Will it fall?
Well, that depends on whether or not you cause it to fall. But that would be you causing that, wouldn't it?
You don't cause the pin to fall at all.
It's not falling. I'm looking. I keep telling you. This pin I'm looking at's not falling, Brenda. What are you talking about? Pins don't just constantly fall. I'm not looking at pins coming down as rain. That's not a natural phenomena. Pins don't just fall. Unless there's a cause. Unless there's a... I hadn't finished. Unless there's a cause for them to fall. Right. And in this instance, you're saying, well, I'm going to pick it up, and then I'm going to figure out what the cause is. Well, no, we established it when you said you picked it up.
Well, picking it up doesn't cause it to fall. Picking it up causes it to rise off the table, doesn't it?
So things go up then. Wow, hold on. So, hold on. We've just got some anti-gravity going on. That's anti-gravity then.
It's not. It's a force. You apply a force to the pin, causing it to rise off the table.
Oh, right. So there's your cause then, like I just asserted.
Yeah.
All right. No need to do any further science then. We've got our cause. Cause and effect has been established. Excellent. No need to go further and establish any causes of any effects. We know what the cause is, don't we? You picking it up.
Picking it up off the table doesn't cause it to fall.
No, it went up.
Yeah. Yes, it did.
Well, that's completely flying in the face of gravity then, isn't it? So apparently things always go down, but in this instance, they're going up.
Right. You think something going up means that it goes down?
Well, no, you're saying it goes up. You've just described it going up. You pick it up and it goes up. We'll ignore the fact that you're doing that, and I'm just going to assert there's a natural force of up, because if you pick up a pin, it goes up. So the cause of that is the upward force. Forget that I picked it up.
You caused. There's
no, I didn't. There's an upward force. There's nothing to do with me. It just went up. I didn't pick it up.
Even though I picked it up. It's an upward force, you dumbass. The upward force. It's not me picking it, Brenda. It's not me picking it up that causes that. It's the upward force.
Yes,
oh, really?
Yes, it is.
So you're now fighting my argument, are you, Brenda, you complete dumbass?
No, I'm not.
So it's not me picking it up, you say?
No, it is you picking it up.
Excellent. So it's you picking it up, Brenda. Yeah. So we're in agreement. You picking up the pin is the cause.
Picking up a pin causes it to rise off the table.
Excellent. Well, that's in complete defiance of gravity. Man, this is just not going well at all. I thought we were trying to prove a downward force, but yet all we've got here is things going up. It's incredible.
You brought it up, Nathan. Shut the fuck up.
No, I didn't bring up picking up a pin, Zynder. Is that another lie?
You didn't bring it up. You said it defies gravity picking it up. Why are you?
Oh, really? Sorry,
like
John.
right
John,
now?
can you just bring up your screen again with what is
Picking
apparently
it up
my claim? We'll just put it back up on screen. Sorry.
Picking it up doesn't defy
Oh,
gravity.
have you deleted it already?
Picking
No,
up a pin.
I'm back on the screen here. What did you want exactly?
I think you've deleted it already when she gave
What's
her
that?
alternative hypothesis of a pin being dropped.
Oh, I took that off. I'm
Oh,
sorry.
yeah, but it definitely wasn't my claim, was it? It was Brenda's.
No, she said
So
it was
picking it up
Newton's hypothesis
picking it
that he
up
never hypothesized.
So picking it up doesn't mean that it necessarily must fall down.
So things don't fall down at all now. So there's no downward force ever. No downward force then.
I said necessarily. I said picking things up doesn't mean that they have to fall down. I can just hold it, right? I can just hold it there.
So how does this affirm your argument in the slightest, Brenda?
Well, because when I release the pin, right?
Oh, when you release the pen, Brenda? When you release it. Oh, okay, okay.
Yes, when
Continue,
I
I'm sorry.
Oh, great. Well, we've got a cause of that as well. You releasing the pin is the cause of that occurrence, isn't it? You caused that to happen, Brenda, now didn't you, when you released the pin?
No, when I released the pin, I didn't cause the pin to fall down.
No, and I didn't cause it to go up when I picked it up. It just has an upward force attached to it. Didn't you listen to me, Brenda? I'm not causing the pin to go up when I pick it up. That's not me doing it. There's an upward force.
You don't think the upward force is applied by your muscles picking it up?
No. Oh, no. I've got nothing to do with it. We'll
Yes, you
just
do.
figure out what the force of the up bit was, ignoring that I did it. Like you're going to ignore you dropping it, right? It's nothing to do with you.
That's correct. It's nothing to do with you.
No, that's right. There's an upward force, and when people pick pins up, it's nothing to do with them. It's just the magical force of up.
When you pick something up, that has everything to do with you, but when you release it, the reason it falls doesn't have to do with you releasing it.
So it doesn't have to do with, and then she describes the thing that caused it being me releasing it.
Gravity takes over.
No, the upward force takes over when you pick it up. The upward force takes over. It's nothing to do with me when I pick it up, Brenda. It's the same principle. It's nothing to do with you dropping it, and it's nothing to do with me picking it up in the air. It's the same.
Right. So when you pick something up off the table, you apply a force to it.
No, I didn't. I didn't. No, it's not me. No, Fundy. No. Stop misrepresenting me. Stop it. Brenda, stop rumpusing. Stop rumpusing with your nonsense. Brenda, can you stop rumpusing?
Pick something up, you
Brenda, I'm going to have to kick you out if you keep rumpusing. Right, it's time for Brenda to go. She's obviously lost so badly that she's going to keep rumpusing. Is this what you're going to do? Is this what you're going to do, Brenda? Keep rumpusing, I'm going to kick you out.
Ignoramus.
Right, time to kick you out. Bye-bye. No rumpusing, sod off.
Okay, let me take over.
Oh, great.
Hold on. Does picking up a lead weight require a force? Your muscle, does it? Yes, I think so. Does letting the lead weight fall require a force?
We first had to get it up in the air, though, didn't we? So, again, you couldn't have the second scenario without you first picking it up, Zynder.
But that is not a cause. It is like saying me pushing the button of an elevator is the cause for the elevator going in on the top floor of a skyscraper. It isn't. It is just you pushing a stupid button. Everything else makes the elevator.
So what's your claim?
Would the elevator come to your floor?
Hold on a second.
If
Are
you
you
didn't push
claiming
that
this
button.
force is gravity?
What?
Are you claiming, Zynder, are you claiming this force as gravity?
No, I don't know what the force is. The force is just a 9.81 meter per second squared downward force. That's all I know.
Yeah, but you're calling it a force. How do you know it's a force?
Because when I let it fall, because when I let it go, I needed a force to pick it up. I need a force for it to go down again.
So,
That's how
so you're
nature
saying
works.
there's a force
So what?
there. Hold on a
What
second.
force is causing
God, this is... We need slick moderating here.
Try once
Whenever
more,
you're
John.
ready.
We need some common sense in here is what we need.
Yeah, I know.
So what forces?
So what are you
what force
claiming,
causes
Zynder?
a balloon to go up?
What is happening here is that when you pick up the pin, you're putting energy into the pin. When you release the pin, that same energy that was used to pick it up is released and it goes back to where it was.
That's not true, because when you hold the pen for 1 hour, there is a lot of energy that is required for you to hold the stupid pen. But when you release it, the same energy gets released as if you would only hold it up for 1 minute.
Okay, now with that scenario, I can pick up a pen, right? And I can set that pen on a table and let that pen sit there for a week. And then I can come along and just nudge it. And that same energy that I put in it when I put it on the table, that held there for a week, will release itself and the pen will go to the floor.
Well, in that scenario, the table has probably a structural integrance that would hold the pen up. But in my scenario, when I lift it up with the arm, I need energy to keep my arm in the air. And there is a lot of energy getting built up. That means that the longer I wait with the pen in my hand, the faster it should fall, or the harder it should hit the ground, whatever, it's the same. But it doesn't happen. The pen will always...
So wait, so if I hold a pen for an hour, it's going to fall faster than if I hold it for 2 minutes?
No, that's what you propose when you say that the reason why the pen falls is because I picked it up.
Okay, what is the cause?
The cause for it falling is a 9.81 meter per second square.
No, that's not a cause. That's an effect. So what's the cause of that?
A force pulling on something is a cause for something moving.
Okay, so we got a little thing called the scientific method that elucidates cause and effect relationships. So let's go through it. Is my screen up?
I don't care about your scientific method.
We'll start off. It's not my scientific method. It's the scientific method. I didn't make it up.
Oh, sure. There are a lot of scientific methods.
Observe phenomenon. The scientific method. It's singular, not plural. Method. Do you have another scientific method?
All right, let me say something. Like, the scientific method, in actuality, isn't a set of sequence of procedures that must happen.
It isn't?
No, it isn't. That's from your citation that you posted in Discord 1 month ago, by the way.
Citation, please.
All right. I can cite it.
And then we're going to need an example of you taking us through this method that you're going to post.
How many scientific methods are there?
1.
Seemingly a lot.
1.
I mean,
so can you count them?
All right, let me finish. That must happen, blah, 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 although it is sometimes presented as such.
Did you say blah, blah, blah?
Yeah, all right, I'm going to repeat the sentence I said before, all right? The scientific method, in actuality, isn't a set of sequence of procedure that must happen, although it is sometimes presented as such. Some descriptions actually list and number 3 or 14 procedural steps. Right? That's what it says. So we have a lot of different sources that say different things about the scientific method, but at the end, it seems to be a semantic game again. So why should your scientific method, or why should the scientific method you talk about be the right one? Can you show me any evidence for it?
Well, you are in this channel, on this channel, as a certain scientific method. So if you don't agree with that method, then maybe you shouldn't be on this channel.
Yeah, no. There's only one method. He had his say. He said there was different scientific methods, correct?
Yeah, like 3 to 13 steps, it says.
Okay, so can you give us those steps? No, we want an example. We want you to take us through scientific validation of a claim through one of those methods.
You claimed science. I didn't. I didn't even say that my example follows the scientific method. So no, I don't have to. take you through any scientific method.
Well, there's a cause and effect relationship, right? That's what the scientific method adjudicates.
So what? I don't care about you.
We're looking for validation.
Method. Why should I follow the scientific method with what I just said?
Because it's a cause and effect relationship. You just said that before. That's why we got on the subject, Zynder. Are you on medication?
I described to you a 9.81 meters per second squared downward force, right?
That's an effect.
That's all.
What's the cause?
Wait, I just want to know.
Wait. That's an effect. What's the cause?
The cause is the force pulling down the pen.
Okay, so we have to scientifically validate.
Do
you agree that the king of the scientific method is experiment?
You brought up the scientific method. I don't have to go through the scientific method again. Why should I?
Scientific method, right? What is the scientific method? Let's start there.
All right. One example of it is for example, here a hypothesis. Like here it says the hypothesis should also contain a prediction about its variability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated, right? That's the...
Right. So what's 1 and 2?
So 1 would be the dependent variable, and 2 would be the independent variable.
Well, that's correct. That's what I was going for. Here we go.
Yeah, but I don't have to follow it because I didn't claim science.
So what are you claiming?
I claim that a force pulls down the pen.
Oh, that's the cause of the pen. So that's cause and effect, right?
Do I have to follow the scientific method
to
describe how I ride a bike?
Well, Zynder, we're asking because Brenda declared that the gravity went through the scientific method. So
do I sound like Brenda, Chocolate?
No, you don't. But you're on her side, right? You're fighting her fight, right?
No, I'm not.
Look, you're not claiming the scientific method for the force of gravity being 9.8 meters per second squared. So how is that being measured?
That's an
How
observation.
is your claim?
That's an observation. The 9.81 meters per second squared is an observation.
How do you measure that speed? Do you have like a
You take an object in a vacuum in order to eliminate the.
Where'd you get the vacuum? But that's not a natural phenomenon.
No, let me finish. You take an object in a vacuum in order to eliminate air resistance. Because air resistance is the thing.
Where'd you get the vacuum? Yeah, but stop. This is natural science. Where did you get a vacuum?
I'm not talking about science. I'm not talking about natural.
Well, we're in the business of scientifically validating claims here.
I'm not talking about science. You are the only one here who's talking about science.
That's right.
Look, let him explain. He's not talking about science. I want to hear his claim on how it's not science that he's claiming that it's his fact, I guess.
Well, an observation of an object falling down in a vacuum can show you the acceleration of every object, no matter if it's a feather or if it's a stone, will accelerate at 9.81 meters per second squared. That's an observation.
In a vacuum? In a vacuum?
Yes.
What use is that? Are we in a vacuum?
It doesn't matter.
Well,
it
no.
Still applies hold
on, Zynder. If you're to say there is a force, and I say, what force? You say, well, we observe it. And I say, well, where do we observe it and experience this force that you say exists everywhere? And you go, well, I put things into a vacuum. And I go, whoa. What do you mean you put things into a vacuum? I'm not in a vacuum. So what relevance does this have?
Well, in air, maybe it accelerates a little bit slower because of air resistance. So what?
So things don't fall at 9.8 meters per second then?
They do if you eliminate air resistance.
Yeah, but we do have air resistance.
So they fall a little bit slower because...
So what's the relevance then? So they don't fall at 9.8 meters per second, as you're asserting. they only do that in a vacuum when you remove the medium that we live in. So this is totally irrelevant to anything.
That's the force I described as 9.81 meter per second per second. That's the
Yeah,
force.
that force only happens in a vacuum, according to you.
No.
It doesn't happen in the world, does it? You said it's a bit slower. So it doesn't happen in the real world, Zynder. It only happens when you completely remove all of the necessary ingredients for life. For me personally, I like air. But you're saying if I remove the thing that you necessitates life for you personally, then we have this measured force at 9.8 meters per second. Therefore, that is the force.
The force applies everywhere.
Yeah, I know your fundy belief. I get your fundy belief. I've heard it. And when we ask you where we observe it, you say in a vacuum. Hands up, who's got a vacuum?
I've got 2 vacuums. Actually, 3 vacuums.
So,
but Zynder, how fast does a helium balloon in a vacuum fall?
9.81 meter per second squared.
A helium balloon.
Yes.
A helium balloon?
Yes.
Yeah, in a vacuum. Is that the same as what happens in the real world?
Isn't the vacuum in the real world, Nathan?
Sorry, my question, Zynder. You said both, whatever you pick, a bowling ball and a helium balloon, both fall at 9.8 meters per second in a vacuum. Is that statement correct, first of all?
Yes.
Is that what happens in my existence generally?
In air, no.
So when you assert that items are pulled to the ground at 9.8 meters per second, and then you put the example of a helium balloon in there, would you not assert that that effect only happens in a vacuum?
The acceleration of the object happens at this acceleration, yes, but the force is still the same.
Well, but it isn't. Sorry, you're saying the force is... Sorry, Zynder. If the force is the same, then objects like helium balloons would also fall with the same rate in air, but they don't. So I'm saying that that effect of objects always falling at 9.8 meters per second only applies in the very unnatural scenario that you set up when you do this and claim it's an observation we see every day in a vacuum that we don't live in.
Well, the helium balloon goes up, the air goes down. So yeah, the air falls down while the helium balloon rises.
Oh, so the air resistance is negative. Is that what you're saying?
No.
For a helium balloon? So how does the helium balloon rise up not in a vacuum?
So why does the helium balloon drop in a vacuum? Or why?
No, why does the helium balloon rise up when it's not in a vacuum? Is it because the air resistance is negative?
No, because the helium balloon goes up, the air goes down. It's an exchange.
But why does just a normal balloon filled with air fall down slower than 9.8 meters per second squared?
Obviously, it is slower, yeah. Because there is an interaction between the air and the helium balloon.
Okay, you're saying it's air resistance, right?
Yes. Air resistance slows down the air going down.
So that's your cause.
Does the effect going up have air resistance?
Yes. I mean, it has to hit the molecules in order to go through the air, right?
The thing is, Zynder, the very thing that you've removed from the equation, the air, when you put it into a vacuum, seems to have quite a strange effect on the assertion made that things always fall at 9.8 meters per second squared. So would you say that that particular variable, given that when it's reintroduced, completely alters that assertion, would you not then surmise that perhaps the air itself has got quite a big factor on what things are doing and why they're doing it? For example, going up, not down.
Obviously, the air has a factor. And
right.
I didn't say that everything, by the way, I didn't say that everything falls at 9.81 meters per second squared. I said the force is measured as 9.81 meters per second squared. Because you have to eliminate all other variables in order to measure force.
You said everywhere. Or you introduced your vacuum. Where do we find a vacuum in nature?
It doesn't matter if it is
This
in
is
nature
natural
or not.
science.
I'm not talking about science. Why do you
This is
always
natural
bring it up?
science. You say you're not talking about it, but you are talking about it.
I'm not
No,
claiming
I was gonna
science.
ask you another question.
I'm just experiencing
This is
things.
natural science, son.
Let me try to help Zynder out just a little bit, maybe. Everything you've described is you're varying the one thing that is potentially the cause is the air. The one thing you can't vary is the force. Everything, removing air in a vacuum, the balloon rising, the pin falling are all the variables. And you can adjust that according to density and buoyancy, the whole 9 yards. But the one thing you can't control is the force. You have to vary the force, not the medium in which all the objects are in. I think that's where you're getting this all wrong.
Yeah, I agree. I can't vary the force. The force always stays the same. Everywhere.
Or there is no force.
You just dream this up.
In water.
You're just dreaming up a force. I can call it anything. I can say it's Ducal Slopelgerts, right? I'm not. I could just claim it, declare it. So
The acceleration isn't the
Ducal
same in water
Slopelgerts.
either, and it's not the same if you tank of helium. If you vary you're varying the material, whatever you're in. If you're in a tank of air or you're in a tank of water, it's not so it's not the same everywhere. It depends on what. Yeah. The force is not the same everywhere. It depends on the medium that the object is in.
So I think what Nathan's saying is it's medium specific, but you're saying that to declare there's a force, you get rid of the very thing that if you did vary it, you'd see alterations. That would be the medium that the item passes through.
All right, so we have a motor that has the same force always, right? It spins and it has a rope attached to it. At the rope, I'm holding the rope, right? And in the air, I am really fast, right? I'm getting direct really fast, but then I'm getting direct through water. Then I'm slowing down. The force that is the motor is the same, but the speed of the person changes. That's the same with the force we experience when we let something fall in a vacuum. That's exactly the same.
Sorry, you
the
say
force doesn't change.
Sorry, we experience. When do we experience? Have you experienced this in a vacuum?
Yeah, I'm experiencing a force right now.
In a vacuum, you just described it in a vacuum using the words "we experience." So have you experienced this in a vacuum?
I've observed it doing things.
Can I get a quick question in there just so I can get a little bit of clarity because I'm a little bit confused? Zynder, in the vacuum, that thing that falls, is it sitting in the bottom of the vacuum when it falls?
No, it was at the top.
Okay, so how did it get to the top?
Someone put it there.
Right. So now when someone put it there, didn't they need energy to put it there?
Yes.
Okay. So now isn't it reasonable to say that when they let that go, that same energy that they put in it just released? Is that a possibility?
It wouldn't be the same energy.
I know.
Yeah.
Okay.
I mean, the energy isn't the same. I'm sorry.
Right, but I'm saying is, okay, here's a question. Let me ask it this way. What happened to the energy that they used to put it up there? Where did that go?
That became potential energy and top of the vacuum chamber.
Got you. So now when they let it go, what happened to that potential energy?
A part of it got released, but not all.
Okay.
Probably less of it got released than it was needed to put it up.
Okay, what happened to the rest of it? Hold on. What happened to the rest of it? Because energy listen, let me explain. Energy can't be created or destroyed. Yeah. So if you put potential energy into that item and only half of it got released when it let go, what happened to the other half?
It transformed probably into heat. And into heat as firm, like, I don't know, into radiation. Form of radiation. in form of anything.
Okay,
so it started
how
glowing in the vacuum chamber.
Yeah, where'd you get the heat from? What was creating the heat? Was it through friction with the air that you've
what
removed?
about the radiation? Where did that come from?
Wait, hold on a second. Don't interrupt this. This is an important point. Go ahead, Zynder.
The heat I was describing was created when the person picked it up and put it on the vacuum chamber. That's the energy that's the energy that was required to put it on top of the vacuum chamber.
No, that's not what we're talking about. You said that there was when it released from potential to kinetic energy, not all the energy was released. You said less than half. So, and then you said that the heat from, what are we talking about? A pin or a feather? Doesn't matter, was released somewhere. So where was it released? And then you said it was radiated. Do you know the three types of heat radiation?
So no, that's not what I said.
It is what you again. Said. I wrote it down.
So he said if the same he asked if the same energy got released as it was required to put it on top. I said no. A part of the energy that was required to put it on top was released in form of heat. That's what I said.
In the form of heat.
Yeah, like he picking it up and putting it on top of the vacuum chamber.
No, when it was released. You just said it when it was released.
No, the energy was released in form of heat when he picked it up and put it on top of the vacuum chamber.
Oh my God. Okay, where's the energy? Where is, I'm out of this.
Not released as if in me letting go the object and then the object getting released. Releasing the energy was released when he made the movement. Right?
I don't know. I'm sorry. You asking me?
Where are we going? I'm lost.
It's this labyrinth of incoherence is what it is. He says something that he says he didn't say it, but he just said it. And then he said it again, and he said he didn't say it. I mean, are you on medication? Seriously.
Can I make an observation about Zynder's vacuum chamber that he probably hasn't thought of? Is there any mechanisms inside the vacuum chamber that are carrying this object up to the top of the vacuum chamber?
My example was me just picking the object up and putting it into the vacuum chamber and then pulling away the air, right? So after I put it inside.
Okay, I don't understand that. That's incoherent.
No, it
most vacuum chambers I've seen is they have mechanisms inside to raise either a feather or a bowling ball up to the roof of the so-called vacuum chamber. Now, the question I have is the objects inside the chamber more dense or less dense than the air inside or the lack of air inside?
So, like, this, for example, let's take a piece of metal, so we can raise it up with a magnet, right? So we have the mechanism, right? And so the magnet or the piece of metal is obviously more dense than nothing, or than almost nothing, right?
So if that mechanism that's made of metal or a magnet is holding a feather or bowling ball at the top of the chair, is something more dense holding it in the air than something less dense?
Like the mechanism itself, if it is more dense, or if the object inside. Yeah, the mechanism is, I would say the mechanism is outside, because the magnet would have to be outside the vacuum chamber in order to hold it.
No, I mean, okay, well, okay, let's put it back in the air. When I pick up a pen, is my hand more dense than the air that's in, or less dense? More dense or less dense?
More dense.
Okay, so my dense hand is actually supporting the pen in the air, correct?
Yeah.
If I let go, the more dense pen gets released into the air, so the more dense pen drops to the floor, which hits a more dense surface, which is the floor.
Mm-hmm.
Correct?
Yeah.
You see where I'm going with all this?
Yeah, you say relative density explains why things fall to the ground, right?
Yep. Because that's the only thing you can control. There's no force involved.
Well, yesterday I think I made an example with like me when, like, you know, when you are upside down with your head upside down, you all the blood rushes into your head, right? So relative density didn't change. You can eliminate facts like pressure differences by going inside a something, or going inside a shield or anything that shields you from the density outside, like the air pressure outside, and then you stand upside right, and then you slowly, really slowly turn around so your head is at the bottom, right? Now your relative density didn't change, but the blood flows into your head.
Can I get a little clarity here? No, I'm sorry. Go ahead.
I'm losing my will to live.
Yeah, I would like to have a conversation with Zynder. So,
people.
You're saying that there's a vacuum in space outside of Earth's atmosphere without a container, but what keeps things from flying outside into the vacuum is the gravitational force of on Earth, right?
Just the force, like
the force, but it has to be gravitational force on Earth, because if they say the gravitational force of the moon is a lot different, is 1/4 of the gravitational force of the Earth, right?
Mm-hmm.
Now, water vapor in a vacuum, how does it form into a cloud? Does it ever condense?
Like a water vapor on Earth,
in a vacuum
of the Earth, on the surface of the Earth in a vacuum, would just distribute itself completely around through the vacuum chamber, and would like it would at some point, I think, it would have to I don't know how it would work. Part of it would become water if the pressure is high enough, because there is water vapor inside, right? But at the end, it would just be a gas. It couldn't form to a liquid.
It wouldn't ever form to a liquid, even with gravity?
If there is enough, like if there is a complete vacuum, even with gravity, it couldn't form to a liquid.
So the water vapor on Earth, the gravity is condensing it to clouds with a vacuum outside of the atmosphere on Earth. So what causes that condensation to form rain clouds? Like at what point in the atmosphere does it work with the vacuum pulling on the outside of the Earth's atmosphere and the Earth's gravity preventing that water vapor from escaping? Like how does it form?
So how do clouds form, you say?
Yes.
Like the atmosphere has a maximum amount of water it can take, right? That's called like when you hear like 100% air humidity, it is at 100% air humidity. There is no more, not much more water that could be pulled, let's say pulled up from the atmosphere. So it is completely satisfied, right? And then the water vapor rises up to a certain point until it I have to add the water has to stick to a solid object in order to form a cloud. It doesn't work if it isn't stick to a solid object, right?
What's the solid object?
Dirt.
Sorry, I'm a bit sorry to interrupt. Clouds don't stick to solid objects.
They have to.
Sorry, show me a cloud attached to a solid object, please.
All right, look in the air. Look how clouds form.
I'm looking right now, and I see no solid object attached to the cloud.
Yeah, you can't see dust from, I don't know, 2 kilometers away.
Oh, okay, I see. So you're saying in order for it to form, it needs to form around a particulate. Okay, my bad. I take it back. I take it back.
Because without dust, it can't form to a cloud. And don't ask me how to explain it completely, because that's just the mainstream that I got it from. Right.
Thanks.
But
okay, now can we get to the meat of the subject? Can you please provide scientific evidence for your spinning ball religion?
No, I never claimed science.
Okay. Thank you.
Perfect. Anyway, gotta go. So.
Okay. I mean, I like this conversation, Zynder. Now, those dust particles, how do they get up there, up into the atmosphere? I mean, wouldn't those dust particles fall due to gravity?
Well, I mean, I don't know. Like, or if you look at it from the relative density thing, a dust particle is usually more dense than air, right? I don't know how it gets up there. There is wind. There is wind that like brings it up. There are like air currents. The Earth is a really complex system, so I have no idea.
I'm sorry, is that Ebon? Is that your name, Ebon?
Yes,
am I saying that correctly?
Me.
Hey,
yeah.
Ebon, you invoke gravity in your question. Where'd you get that from?
No, it's just I just want to learn more from Zynder about how gravity and vacuum kind of work in relation with water vapor, dust particles.
Wait,
air,
shouldn't we, before we go extrapolating down, making a question fallacy on acid, shouldn't we establish what gravity is?
Well, Zynder can establish it however way he wants. It doesn't have to be scientific. I just want to hear how it's formulated in his mind.
What do you mean?
I don't know what gravity
is. That's what science says. No idea. I've seen in the science book, gravity, it has to be science, right?
But he's not claiming science.
Hold on, he's just said he doesn't know what gravity is. Is that right, Zynder?
I have no idea what gravity is, yeah.
So how the hell would you know that it holds the atmosphere?
Well, I can look at something and see its effect, but I don't know. I don't have to know what it is.
Like, don't know what it is. How do you know it's the effect if you don't know what it is?
Well, I experience it. I experience a force.
No, you don't.
But then we go back. We
went
go back
through this.
to the
No. We went through this earlier.
I'm sorry.
No. The force you described, we went through earlier, and you said that's demonstratable in a vacuum. So no, you don't experience that. We went through this earlier. No, that's not part of your experience. Things falling at 9.8 meters per second. You don't experience that. In fact, that never happens. Ever.
Never, ever?
No, not in your experience, no.
It's me looking at something, experiencing something.
So you can look and watch and experience anything ever falling at 9.8 meters per second. That happens, does it?
No. But it's me watching
so
something,
it doesn't happen. That's my point. What do you mean just no and then carry on talking? So it doesn't happen ever.
It happens.
In your experience, that happens, does it? We're going around in circles, Zynder, with you declaring that you experienced this, only to then confirm it never happens ever.
I didn't confirm it.
Yes, you did.
It's me looking at it. It's me observing something and experience.
Yes.
Yeah. Yes.
So
are your eyes calibrated? How do you know it's 9.8 meters per second squared?
Because it was measured. The speed difference was measured.
Where is it measured?
Observe.
Where?
In a vacuum chamber.
Well, that's not your experience then, is it? That's in a vacuum chamber.
Observing.
That's in the experience of a vacuum, not your experience then, Zynder. So the problem being that experience, the experience of a vacuum that no one's ever experiencing, is completely contrary to what we actually experience when you declare there's a force that you don't know what it is at 9.8 meters per second in a vacuum, not in your experience. In fact, the experience is completely different. Helium goes up, yeah?
Is me watching something, experiencing something?
So you experience...
Is it only in German?
So you experience helium going down at 9.8 meters per second. You experience that, do you? In your experience, that happens, does it?
When I see something, I experience something.
Yeah, so you experience 9.8 meters per second towards the ground when you release helium. Do you, Zynder?
Depends where it is inside.
No, just in our experience. We're talking about our experience. Reality, Zynder.
The real world. The real world is everything that is a part of the world.
Yes, and in that, do you experience helium following this 9.8 meters per second acceleration towards the ground in your experience or not?
Yes.
So helium goes down.
When it's in a vacuum chamber, yes.
No. Are you stupid? God. Do you know what in your experience means? When have you experienced a vacuum? Go.
When I looked at it.
That's experiencing it, is it? So if I look at a Lamborghini on my screen, that's experiencing a Lamborghini?
No, when it's not, then you experience a
Yeah,
Lamborghini
when I get inside that Lamborghini, I'm experiencing it though, aren't I? So when are you getting inside a vacuum and experiencing it in your day-to-day experience? Does that ever happen, ever? Have you ever been in a vacuum? So you've never experienced a vacuum? Let me get it straight. You have never experienced this. Precisely my point.
I experience vacuums all the time.
When?
My lung is based on forming a vacuum.
Wait, Zynder, you don't see the double speak that you're doing right now? You can't hear it at all.
I'm just playing a stupid semantic game. What's your point?
Okay.
Like everyone here does.
So when you watch the astronauts go to the moon,
no, what you're doing is making your horse's ass out of yourself in front of how many people are watching?
Is it even live? I can't even see the live debate right now. So since like a lot of time.
So you're not
experiencing it?
Yeah, 150 people watching this now, Zynder.
Oh, great. Are you streaming on Nathan Oakley or Nathan Oakley 98?
Indeed,
Nathan Oakley normal, perfect.
Yeah. Yep. Yeah. Everybody's witnessing what a horse's ass you're making out of yourself, sir. Good job.
I'm just playing a semantic game. I don't care.
Yeah, you're just playing semantics. What does semantics mean?
Like different meanings of words, for example.
So, would you say semantics is kind of important when people attempt to communicate with each other?
Sure.
So, what's your point?
The question? But the semantics are important in the context. Semantics are completely useless if you take it word by word.
so the meanings of words are completely useless if we take it word by word.
You need a context of words.
We need a context of words. Give us an example.
Yeah, words alone don't mean anything. You need a context to the words.
Okay. Give us an example. Like, let's say in our experience, right? The semantics of the word helium balloon rising, not falling at 9.8 meters per second squared.
Yeah, when I mean air, or when the helium balloon is in air, I experience it rising. When it is in a vacuum chamber, I experience it falling. What's the point?
Oh, you don't experience a vacuum chamber. Do we live in a vacuum chamber?
Like when I looked at a vacuum chamber, I experienced a vacuum chamber.
Yeah, man, anybody who wants to own a Lamborghini and fully experience a Lamborghini, just look at one and you will get the full experience. You don't need to save up. You don't need to buy one and drive one. Just look. Then you experience fully. Like Zynder looking. Because that's a total experience, isn't it? That's in your experience because you've looked.
Or if you want can I tell you my experience of a balloon? In a vacuum
hey guys, I was trying to get some clarity for about 5 minutes from Zynder. Can I just get this one clarity?
No, let me just respond to it. Like, is it in English? Don't you say I experienced a movie in a theater, or is it wrong? Is it a wrong sentence?
Yeah, if you were to assert that you'd experienced hell because you were watching a movie of hell, then yeah, that would be semantics, wouldn't it?
No, I ask you a question. Do you experience a movie in a movie theater? Yes or no?
Yeah, I experience a movie in a movie theatre, but I don't
Yes,
experience the fires of hell because I've watched them on a movie screen.
No, you didn't, obviously.
No, so I didn't experience the vacuum by looking at it.
I didn't look at the vacuum at the screen.
Can I just get some clarity? Guys, I've been trying to clear.
Let's look at this.
Yeah, go ahead.
I was trying to clear up a point for 1 second. Zynder, you said a little while ago that you were just here goofing around, correct?
Yeah, I'm playing a semantics game.
Okay, where you? Okay, I heard you. I heard you. Now, when you said about this force you were talking about, you were just playing a semantic game. You were just kidding. You're not really serious about this force. You're just playing with us, right?
Sure, I'm always playing when I'm come here. Sure, why not?
So this force that you're talking about is just a joke, right?
Yeah, everything is a joke. Like,
okay. I just wanted to clear. I just wanted to clear that up. I just want to clear up for the audience that gravity is nothing but a joke that people play games with when they make these declarations. They're just kidding. They're not serious. So don't take them seriously. When somebody's talking to you about this force that pulls things to the ground, they're just playing games with you. It's just a joke. So don't get involved in it.
Yeah, I would agree with that. Zynder's declaration that it's just a joke and a game of semantics rather than actual scientific evidence of some force that we experience. But with that, I will say, unfortunately, to the live audience in the Nathan Oakley channel, this is where we bid you farewell. You need something to keep you occupied after this live stream has ended, then go to nathanoakley.com and check out the Flat Earth Debate Forum to keep up to date with the community debate. If you're watching on Nathan Oakley 1980, then stay tuned as there will be an after show to follow. I've been Nathan Oakley and I'll see you all in the next video.
Oh, what a day! What a lovely day!
No, it doesn't, because it's in a movie.
Yeah, because it's a movie, because it's production, right? So you say your experience watching something on a screen makes it your experience. So when you watch the astronauts land on the moon, does that make that real?
Only because it's in TV. Only because it's on a screen. No, it doesn't make it real. But it makes my experience.
When you watch a video of bowling ball and a feather falling down in a vacuum chamber, does that make it real?
Yes, because I see a vacuum chamber in front of me, and it happens. It is in the real world. It isn't only on a screen.
No, but does that mean you experience it? When you watch the Apollo film, did you experience going to the moon?
No, because it's on a screen.
Did you experience 1/6 of the gravity? Did you experience the takeoff? Did you experience the ride there?
No.
No,
because
so it's the same thing. You can't. It's not just because you watch something on the screen doesn't make it reality, and it's in a vacuum chamber, and we don't observe vacuum chambers in reality.
All right. Do you experience a car?
No, we're not doing this anymore.
Is the
vacuum chamber? Let me ask you: is the vacuum chamber in a container?
Yes. So what?
So
John,
how do you have gas? How do you have gas pressure without a container?
It wasn't even the discussion.
Well, yeah, we're changing it because this is a train wreck. It's a never-ending train wreck with you, so we're stopping it. So how do you have gas pressure without a container?
John, you'll like my comment if you'll just hang on, Zynder. Let me ask you a question, or to tell you a statement. Do you know what my experience of a helium balloon in a vacuum chamber is? My experience.
God.
What is your experience?
It pops.
The balloon explodes.
Yeah, it pops.
Yeah. And then the rest of the balloon falls down, right? The rubber. And the gas.
No, Zynder. No. That's something that you need to maybe familiarise yourself with. The second law of thermodynamics. So the gas would fill the space.
Yeah, and the rubber falls down. Why no?
Yeah, the rubber, but the gas, the helium, the thing we were actually talking about, that fills the available volume once it becomes available to it.
Yes, I never said something else.
Well, your entire religion states the direct opposite.
Like, when you ask gas pressure without a container, does it have to be a closed container or does it have to be an open container?
A container.
Any container.
Containment. Container, containment. For gas pressure, it has to be a closed system.
So closed container, right?
Closed container. Yes.
Okay.
Yes.
Hey,
Yes.
so kind of going back to.
Hold on.
Wait. I just want to circle back.
Wait.
This is pertinent.
We're getting there.
Please.
Gas pressure gas pressure needs a container. Is that correct?
Gas pressure on the surface of Earth needs a container.
No,
yes.
no, gas pressure, gas pressure needs a container. It's the necessary antecedent. Without a container, you don't have gas pressure.
A container on Earth?
Oh, God.
Or a container not on Earth?
Container.
Have you ever been
anywhere
not
to
on
have
Earth,
gas
Zynder?
pressure?
Have you ever been
anywhere?
in space?
You need a container. It's the necessary antecedent.
Look, you're not going to win a semantics argument with Zynder,
right?
because it doesn't matter to him. Okay,
it's
so
not semantics.
The best thing we can do with Zynder is have him
semantics.
explain certain things.
Not semantics.
And have him explain it, because semantically you're not going to win any argument.
It's
with
not.
him.
So who's
okay?
speaking?
So
who's speaking?
What I want to ask, okay?
Who's speaking?
He knows.
You're
he
not
knows
stepping
how.
on me.
He
I
knows
just
how
asked him a question.
rain clouds form within the vac. He
Stop
knows how
interrupting.
rain.
Tell you what,
Look,
I'm just going to talk all over you.
You've been at this
like
for a
the
long
way you
time.
did
May
to
I
me,
just get
Ivan.
in my
Is this
2
Ivan?
minutes, please?
Is this
Just
Ivan?
2 minutes. I mean, why won't you let me get 2 minutes?
Come on.
All it is 2 minutes. I know you like hogging up the airspace, but I've pretty much been quiet for the last half hour.
Yeah.
I
7
would
minutes.
like to circle back.
You guys
Okay,
have
so
7
just
minutes.
2 minutes. I would like to
Ask him a
say
question,
something to
Ivan.
Zynder
So
and
keep
ask
on
him a
talking.
question.
I'll just
And I don't know why it's so hard for me to have
Ivan.
these 2 minutes.
Right? Ivan.
May I have
Not
these 2 minutes? Because
asked him a
it's pertinent,
question,
and I'm going to be quiet for the next half hour to an hour, just like I have been. Okay, my 2 minutes. So Zynder.
Oh my God!
You know how to make it rain on Earth, right? You've got the water vapor, you've got your gravity, you've got your vacuum. That's not in a container. You've got dust particles. Now, can you make it rain? Can you form rain clouds? And can you make it rain in a vacuum that you have that you can observe?
Rumpusing each other, John and Eben. You're just rumpusing each other if you can't come to an agreement.
I know. I would just like 2 minutes to say something and have Zynder explain it, and that's it.
Well, no,
I'll leave.
I'd
After that, 2 minutes.
I'd like to talk to Eben.
Of course you would, because he's going to get you out of this rut.
So I have.
Go ahead, Ivan. Just step all over me. You're another friggin' clown.
I have 7 minutes.
Okay, so this is
on
take
Earth.
2 minutes.
I have 7 minutes left on Earth.
Okay.
Then I have to leave Earth. I'm sorry, guys.
Sure.
I'm so sorry.
So question that I have for you, Zynder, is if you know how to make it rain on Earth. You've got the water vapor, you've got gravity, you've got vacuum, you've got dust particles. Can you make that happen or have that occur in an isolated vacuum?
No, because rain requires the water to be liquid, and that doesn't happen in a vacuum. Water can't be liquid in a vacuum without pressure.
Okay, thank you. I'll see you guys later.
See you, Ivan.
Yeah, see you later, Ivan. You friggin' clown. Take that
5
with
minutes.
you. Unbelievable. Okay, back to the question, since you got 6 minutes left, right? Can you have gas pressure without a container?
Let's say 47.
Yeah. Can you have gas pressure, Zynder? Listen to me. Can you have gas pressure without a container?
Where?
Anywhere.
Like an open container or a closed container?
It's a closed container. Container means closed. Contain.
No. It's like an open bottle, isn't it? A container.
Unbelievable.
Yes or no?
Unbelievable. You're a little
so let me just. So the question is, can you have gas pressure without a container? So if you're saying, well, okay, open container. Well, okay. So can you have gas pressure inside an open container?
Yes.
Can you show us?
Okay. Wait a moment.
Is this going to be sulfur hexafluoride?
Yes.
Right.
Oh, I got something for that.
And it is gas pressure. And
Show us the video.
sulfur hexafluoride is, you could say, it is pressing on the air above, but the problem with that is that the air above has a lot of empty space in between, and the sulfur hexafluoride has less empty space in between. So
let's see the video.
How does it keep inside?
Let's see the video.
Wait, let me jump to the part where they put the boat inside.
No, jump to the part where it says 0.00, and then can you tell us what that tank is behind the open fish tank is?
Damn it! Why can't the screen share anymore? No, after I reinstalled complete Windows, I couldn't. Why can't the screen share
anymore? When your video comes up, right?
I can't screen share.
Oh, here it is.
I can't screen share anymore. I'm sorry. I'm so sorry, John, to let you down. I'm
too
really
bad.
Okay. No, hold on. Let's just get this back on track. So it's okay. We've all seen the sulfur hexafluoride video. So just for the audience's benefit, there is a glass fish tank, and a guy wheels in a cylinder, a container that's closed, containing the sulfur hexafluoride. They then put a cardboard lid over the top of the container, and then pump the fluid from the container into the fish tank, whatever you want to call it. Then they remove the piece of cardboard, and you've then got essentially an open container with sulfur hexafluoride in it, and then they float something like I've forgotten what it is, a foil boat, I think it might be from memory. Is everyone in agreement that that's what the video shows?
Yes.
Zynder, you
yeah, I've
agree?
seen it. Go ahead. I've seen it.
It's more important that Zynder agrees.
Yes, I agree. And let me add to the reason why they closed it, right? Because of the air currents. So they closed it so the currents wouldn't just push out all the sulfur.
Yeah, sure they did. Sure they did. Thank you.
Okay.
Yeah, sure
Next
they
question.
did. We're gonna need from the people who made the video the air currents inside the classroom. We're gonna need the people that conducted that. We're gonna need a statement from them about the air currents. Go ahead.
No, the air currents comes in when they push in or when they pump in the sulfur hexafluoride, because when you pump in a liquid, when you pump in a gas, you will always get air currents.
Okay, my question is, why did they bring in to the classroom with the sulfur hexafluoride in a cylinder in a closed container?
It wasn't completely closed, right?
Yeah, it was. It was a
little
cylinder of sulfur hexafluoride.
When they pump, let me see, when they pumped it in.
No, when they brought it into the classroom, the sulfur hexafluoride was in a cylinder, like in a acetylene cylinder, right?
Oh.
Why did they need the cylinder?
In order to keep a lot of sulfur hexafluoride in a place without it dispersing everywhere.
So a gas pressure within a container.
Yes.
In other words, yeah, right. So that proves my argument that they need a container, closed container, to maintain a gas pressure.
1 minute left. Sorry.
Hey,
yes.
Zynder, I'll ask you a question about that too.
We live in a container, sure.
Yeah.
Now, does it make the...
Get some quotes around that.
Perfect.
Yeah, we do.
We
that
are
wasn't
living
my point.
in a
My
container.
point was that the sulfur hexafluoride, when they brought... Hold on a second. My point was...
Hold on, Zynder. Don't rumpus. Don't rumpus. Come on, be fair.
Me or John?
Oh my God. My point was that when they brought the sulfur hexafluoride into the classroom, that it was in a cylinder in a closed container. That's my whole point.
Yeah, and that's why I said we are living in a container.
Yeah, we are in a container because we have gas pressure. Exactly.
Do you know the lyrics? I forgot it, to be honest.
The lyrics of what?
We're all living in a container.
Zynder is really trolling today. It's hilarious. Zynder full troll status today. Good shit, Zynder.
Let me ask you one question before it disappears.
I think that was from Ronstein.
Hold on. Have we got time for one more? Hold on. Have we got time for one more question, Zynder? You've been a real good sport.
Sure. I'm sorry.
Can I ask it?
Yeah, Paul. That's what. Yeah.
Okay, inside of where the whatever that gas is, and the outside of the tank, inside the tank, did they measure the gas pressure inside of each one?
No, I don't think so. But I think you could calculate the gas pressure of sulfur hexafluoride inside the container, probably.
Could the pressure?
But it didn't stay. I don't think that it.
Could the pressure be the exact same?
Could it? Good question. It is denser, but only because it's denser does it mean that there is a higher pressure. Probably not. But I think the pressure difference would be almost the same, but not completely the same.
You know what we'd like to see with this demonstration? You know what we'd like to see with this demonstration? For them to bring the container of sulfur hexafluoride in, right? And then put the gas into the fish tank with the cardboard covered over it, and then take the cardboard cover over it, and then I want them to leave for 1 hour and then come back and float that aluminum friggin' boat in there. That's what I want to see.
1
hour.
Have a better idea.
Okay,
1 hour.
Okay, I have a better idea. We should build a lot of tinfoil boats, and then give them little cannons, and then let them shooting at each other. Let me finish.
And then you could smoke them.
No, let him make his joke. Come on.
Yes. And then, like with the cannons, like them shooting at each other and letting Pirates of the Caribbean music run in the background. Like a gigantic container with those boats on top of it, and everyone is really, really happy that what they experience.
Oh, what a great story!
How long you got left, Zynder?
Acumen is
have a nice day, guys.
Thank you, Zynder.
Wait, Zynder. Is the Earth covered in sulfur hexafluoride?
He's gone. He's gone. He did say he'd only got a limited amount of time. No,
you know, before you round up, I'm sorry, can I get one more last word in? The guy told you he was playing. Why are you having a serious conversation with somebody who's told you that he's playing with you? That doesn't make any sense. Yeah, but the thing is that they're not serious. They're just playing a game. So you can't have a serious... That exposes them.
Yep.
I'm sorry.
What else are we going to do, Slick? Nathan's not kicking him out. What else are we going to do? He keeps on talking. You got friggin' Ebon. I don't know what his problem is, but he better figure it out. Right? I mean,
it's just that once I saw Zynder start playing games, I realized at that point there was just no sense in having a conversation with this dude because he's just playing.
But you're right, but that was excellent, Slick, but for the fact that you did that, that wouldn't have exposed that fact. That essentially, when he's saying at the start, quite boldly, we've got gravity, it's a force, it holds the air to the earth, right? Well, at the start, he's quite determined in his assertions. At the end, well, this is just a joke, it's just semantics. Yeah, I can't prove anything. No, I don't know what gravity is. But the audience gets to see that.
I got you. It's just that it seems like people were taking him really seriously, and the dude was just obviously flipping back and forth. And when you're having a conversation with somebody, you can't have a conversation unless it's a serious conversation. If you never know when this person starts to play, when he's serious, then he plays, then it's just it's like a futile exercise. It's just, you know, kind of, that's all.
Not necessarily, because he actually admitted that there was density inside the tank. He actually admitted that. In my last point I was trying to make, because the pressure was equal.
Yeah, but the elephant in the room is, how did they get the sulfur hexafluoride into the classroom to begin with?
Oh, I agree with you.
It's in a tank. It's like a cylinder, a gas tank, right?
But the thing is, they don't really believe in their model like they're claiming. It's just a joke to them. When they're having a conversation, they're not serious. They don't really believe in gravity and believe in the globe, and they're just joking.
No, you're wrong.
No, they do.
No, you're wrong.
Well,
you're wrong.
Do you see now why people get frustrated with this shit?
No,
that's what I said a little while ago. I can understand why people flip, because they're just playing games. They're not serious about no model.
No, but I've got to correct that. You're wrong. at the start, he's dead serious. Zynder thinks he lives on a ball. He's definitely a baller. And he believes this stuff. He thinks we're all stupid, and he believes that too. Now, he'll only take the position that, oh, well, it's not really that important, when he's had his ass handed to him. So, yeah, he'll say that, but it's just an obfuscation of the fact that he's had his ass handed to him.
Okay, but here's my point. When you seriously have something, you don't have to play because you really have something. If I really got something, I'm not playing no games. I'm coming serious. So the fact that you come to me playing games, that already tells me that you don't really believe in your product. You can't.
I agree.
Because you would be serious about it. Now,
I agree. Now you've rephrased it. I agree with you because, yes, absolutely. That's why those specific types of people who somewhere in the back of their mind, and let's use Conspiracy Cats as an example. So Conspiracy Cats, when he's describing the stress he feels when he has to contemplate the reality that he's been lied to on multiple levels, and then details how he's losing sleep over it, he's another one of these jokers that comes along and just says, well, I'm just here to troll, right? Well, no, that's the people who enter this arena because somewhere in Zynder, in this example, in his cognition, he understands some of the contradictions. He wouldn't be here otherwise. Now, your average Joe, who you, by contrast, who you're saying, well, no, they do fully believe in this. Well, they're not going to come because they've got the dogged assurance that they're just right and they don't need to ever argue about it. But Zynder is here arguing about it, isn't he?
Oh, yeah, no, right, I agree.
Can I point something out real quick about the sulfur hexafluoride? It's false equivalence. It's false equivalence. I mean, sulfur hexafluoride is not oxygen. Our planet, our Earth is not covered in sulfur hexafluoride. It's covered in oxygen.
Yeah, that's right.
So
and it's not natural. Yeah, it's not natural science. So sorry for stepping on you. Sulfur hexafluoride is a man-made gas, right? So immediately falls outside natural science.
Not according to Berkeley. I've just had this quoted yesterday. So basically there's a citation going around from Berkeley where they basically say all of the elements in the physical universe. Now, when this was first quoted to me, I didn't quite twig the subtlety about what they were saying, and I focused on different elements of it. But when I saw that Tim Osman had mirrored my conversation with Channel Q, Skyfly Bright, and P Mars, I went through the comments and found Nummy with a slightly different interpretation. And from his links, I managed to find my way to what the hell they were talking about. And I felt quite stupid when it suddenly dawned on me. When they say elements, well, that's specific within science, isn't it? What's an element within science, John?
What's an element within science? Look at the periodic table.
Precisely. So when they say, colloquially, all of the elements in the universe, they're not meaning the colloquial everything when they say that. So if they meant everything in the universe, they'd just say everything in the universe. But it's a scientific citation, and it's specifically saying all of the elements in the universe. Now, the citation goes on to say, including, very specifically, man-made, yeah? But then, again, like I say, after digging through the citation, I think it might have even come from Berkeley themselves.
Yeah, we've been through this before. It's the smiles.
The added ones, the extra elements, right?
No, they added the smiles. Ready? The smiles and the artificial sweeteners. This is the same one. This is Berkeley. This is the Evolutionists Are Us site.
Oh, okay. I didn't appreciate that. What I did appreciate was that they've got certain elements that have been created specifically by man that would fit the criteria, but they are definitely man-made.
Right.
Well, Berkeley would then therefore say that the man-made elements would also fall into the category that can have science applied. Now, without getting into, and I didn't, the aspect of the pseudoscience that would be applied in that regard, I would say no, when they refer to including man-made, they're specifically referring to the man-made elements.
Right, right. It's the same one that we talked about, I think it was 4 or 5 months ago, where we got into this natural versus man-made subject. It's the University of Berkeley. And remember, we went through, and even you were laughing when at the end of their little article, they had science can also look into smiles, emotions, artificial sweeteners, right? Remember that?
I do now. Now you've said it twice. Yes, I do remember. The science of smiles. Yes.
Yeah. That's the same one that they were. And who did that? Nummy Dum Dum.
Yeah, Nummy Num.
Yeah.
But once again, and I just want to reiterate this real quick. All of these people, like your 10 Osmonds, your Rumpuses, these people don't really believe in their product, do they?
Well, when it gets to the point, I think they do believe in their product.
This is my point. When I'm backing something, I'm backing it 100%. But they don't back their product 100%. They just start playing. And who does that with their product? Nobody toys with their own product. Don't nobody play games.
No, they do.
You got a classic. Go ahead, Nathan.
I was just going to say, yeah, they do. I've been in sales. I've sold enough polished dog turds in my time to know that you can get 100% behind a product only to find somebody shoving all the flaws in your face. And you've got to do something, right? Well, you try and downplay
my point is,
it.
Nathan, but you didn't really believe in that product, did you?
Yeah. If I'm selling it.
No. What I'm saying is, you're selling somebody a crap.
These guys
that you know.
These guys that you're talking about, you have to take each individual at their merit. Now,
let me make my point, John. John, let me finish first.
Oh my God, just stop. You already made your point 5 times. I know what you're saying. Right? I already know what you're going to say. You said it 5 friggin' times. What I'm trying to tell you is that you have to take each individual separately. So, if we take Rumpus, for example, he actually believes he lives on a spinning ball. There's no doubt about that. Now, Zynder, yeah, I can understand it. He says he's joking. Yeah, I don't think he actually does believe it. You see what I'm saying?
Oh, come on, Slick.
Well, no, I was trying to talk, but you just basically cut me off and told me to shut up, so I'm doing it.
Oh, so we're going to play the second. I already know. You already said it 5 times, Sick.
Listen, I was trying to make a point, but you just cut me off. You don't know what I was going to say. You
said it 5 freaking times.
Then why are you talking to me? I was trying to stay on mute.
Oh, my God. Give me. Hey, Nathan.
I don't know what's in the air today. I don't know.
I don't know either. I've about had enough of this nonsense. It's 2nd grade playground nonsense. I've reached my friggin' limit, right? I'll talk to you later, brother. Sorry.
Okay, no worries. Thanks for joining.
Okay, so can I finish that point I was trying to make, Nathan, before you round out?
Can.
Okay, what my point is like people like Rumpus and all of these guys, when they start calling you all kinds of names and all that stuff behind their own product, I don't think they really believe it, because they wouldn't do that. They would stay serious. No salesman that really believes in his product is going to play games with it if he really believes it. Now, if he's got a product that he's selling and he really thinks it's crap, but he's going to push it on you anyway, well, he still doesn't really believe in the product, even though he'll sell it to you. But deep down inside, he doesn't believe in it. And that's the point that I'm making. I'm thinking these people that come on the show in comment sections, I really don't think they really believe in their product. It's just an opinion. I could be wrong.
Fair enough. I mean, let me make a slightly different scenario then, so it's easier to maybe make an equivalence. So rather than the product being bad, let's pretend for a moment that the manufacturing is slow and the distribution is poor. So you go in, you're 100% behind your product, you tell them all about how wonderful it is and how fantastic it is, and then they point out flaws, the customer that is, like we are. So in this scenario, we're the customer, the flat earthers are the customer, and the salesman is the globehead, and he's pitching his product and how wonderful it is. But we point out some of the flaws, and it's equivalent to a customer pointing out the flaws in the distribution network or the slow production time. Yeah? So it's not that you wouldn't necessarily be 100% behind the product, you just realise that there's areas that maybe are beyond your control, that haven't got a good enough backup with the logistics. And in the case of the globe, they just apply the same logic. Well, that's an area that, yeah, maybe we haven't got a good enough explanation for, but it still doesn't make it untrue.
Okay, so based on that scenario, if I go in the store to buy something and there's a problem with it, like you said, is the salesman going to start joking around and kidding with me and laughing?
Yeah, so I'm not going to say I do this, but I'm just going to give you an example of a salesperson that could do
No,
this.
but what I meant, but let me clarify. Would you start insulting the customer?
No, because that's a heated debate as opposed to...
That's my point.
They're not
See,
trying
that's
to...
what they do. They start insulting. See, so that's my point. When you standing behind your product, you don't start insulting the customer because the customer brought up a couple flaws. But that's what these people are doing. They're going into an all-out assault on the customer because the customer is pointing out a couple of flaws in their product.
Yeah, well, there's where we reach consensus then, because that I completely agree with. You know, in this instance, they're not actually getting money off us to buy their product. We've just got to have a religious acceptance of their product, and without that religious acceptance of what they're selling, metaphorically speaking, pitching, then they will ridicule if you don't accept it. So yes, I do totally understand, but there wouldn't be a necessity to, and yeah, there would be salespeople that don't have watched it happen. You know, where the customer points out a flaw and the salesperson goes on the attack. Quite literally. So I have seen that happen.
I've seen it too. I've seen it too.
Right, but
actually, there's all I was going to say is I've actually seen. I think what happens in this environment, when you start going after ad hominem attacks or you're making jokes, you're probably hitting a nerve, and that's the only way they can react. I think Zynder shifts gears because once he realizes his ground is getting shot to pieces and he's got no place to stand, he's only got one place to go.
But doesn't that mean that he's realizing
that shifting gears is already in play before he even comes in? Zynder's very good at being in control. So that's already in play. He's already got that planned out before he ever clicks that link, which is sometimes what is frustrating. Could be fun, but sometimes it's just... Yeah, go ahead. I'm sorry.
No, you're fine. No, I mean, you're probably right about Zynder. I'm just thinking of generally people in general. And I've noticed that too. Like when I've gotten a discussion with people like over the vaccine issue, when I actually start dismantling their argument, they just say, "Oh, well, you could do the same thing," or "Oh, you're this way," or "Oh," they go after me, and I've just demolished their argument. You know, it happens all the time. And I see it a lot of times on here when I've been on here. It's kind of funny.
Well, that's just words. That's just words and their meanings and stuff.
But when you have a good product that you stand behind, you don't have to throw insults at the people because you believe in your product.
And I mean, I have a real life example about a problem with our product because even here, I do internet sales, TV and internet service. And we have at one of our areas, they're having a capacity issue right off the bat, and I'm out there trying to sell it. And of course, they've heard in the neighborhood that we're having speed issues. So I don't bring that up initially to the customer. Oh, we're having speed issues, because I know they won't want to buy my product at the moment. But when they do, I've got one of two options. I either can lie to the customer or obfuscate the problem or tell them the truth. And I've actually come to the point of telling them the truth because I think in the long run, it will work more beneficial to me. Say, look, we do have a problem right now, but we are working on it, you know. And I think when I come back, I'd say, look, we fixed the problem. You want to give us a try, you know. And then, but I think that helps me on that side of things for the trust of the customer. I think what they don't realize in any discussion, even giving a little ground, builds a little bit of trust and opens up a little bit more dialogue, because there could be a problem, you know, on either side. But if you're not willing to at least take a look and say, well, there could be a problem, you can't get anywhere. I think that's part of the problem with the Globe side. They're not even willing to say there's a problem.
Well, that's where it switches, right? When you make that decision to say, all right, I'm going to be honest to my customer, you know, just because, even if it's for whatever reason, but even if just to be honest, right? You know, these guys, they don't do that. They can't concede any points. They can't at all. And they make the decision, even if they could concede it, they're not going to concede it. And that's where it's aggravating, because it's like, where's the honesty in this debate? Where is it? Why would Brenda say something like, yeah, gravity has been through the scientific method, knowing damn well it hasn't been? but she's gonna try and obfuscate and play around with the game, with the words, and I mean, it's nonsense, man. It's nonsense.
That's the cognitive dissonance.
Yeah.
They just, even when we prove them or rebut them and invalidate their argument, they will still grasp at any straw that they can. She contradicted herself like 10 times in one sentence. I don't even know, like, she's insane. That person is insane.
I even at some point I told her, why don't you Google it? I mean, if Newton came up with a hypothesis for gravity and it's been through the method and all that, shouldn't that be out already? Why is that something she has to formulate in her head? I should be able to Google in 2 seconds what was Newton's hypothesis for the gravity, and that's that.
Yeah, you know what you get if you do Google it. John brought it up on the show. I make no hypothesis for gravity is roughly the translation.
Exactly the point.
Cool. I think I might round out the after show on that note. So I'm going to say a huge, massive, enormous thank you once again to all of the debating panel for making this after show possible. And of course, a massive, huge, enormous thank you to all of you in the Nathan Oakley 1980 premiering stream for tuning in, subscribing, hopefully smashing the super chat and all that good stuff. If you need something to keep you occupied after this premiering stream has finished, then go to nathanoakley.com and check out the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!